In the video on state, I discussed how useful it is to think of all of your global variables as something called state. This way, every time Draw wakes up, it consults those global variables and produces a picture. If Draw changes those variables, or the keyboard does, or the mouse does, that's great. Then next time Draw wakes up, it uses those variables in whatever form they are and draws a new picture. This idea is so important, I'd like to show you another example of using state. In this example, the state variables are modified by the keyboard and the mouse and by Draw. Let's look at the running program. Here's the program. I call it the fox and the hen. We're looking down on a grassy field, and in that field there is a fox, and the fox is this little fox-colored circle. There's also a hen, and the hen is this big white circle, and the fox wants nothing more than to catch the hen. On a real farm, maybe the fox would eat the hen. Here, the fox just wants to catch up with the hen. So right now the fox has caught the hen, but the hen is connected to my mouse. So if I click on the hen and I start to drag, the fox follows the hen because the fox always wants to be with the hen. If I start moving the hen faster, the fox starts to lag behind, and if I move the hen much faster, the fox really falls behind. But if I slow down, fox catches up, and if I stop, the fox lands right on top of the hen. So there's a really nice behavior here in that when I'm moving slowly, the fox is with me, it gets further and further behind, and if I start slowing down, the fox catches up. For fun, I'm going to turn off the clearing of the screen for every frame. So now both of these guys are going to leave a trail behind. And you can see that the hen, the white circle, is a little bit jittery and bouncy because I'm dragging my mouse across my mouse pad and it's catching a little bit. But the fox is nice and smooth. The fox is smoothing out the hen's motion as it chases after it. If I slow down, the fox catches right up, and if I speed way up, the fox falls far behind. If I go nice and slow, I can get both of them to leave trails, and I can make some nice shapes. I can make a little loop-to-loop here, and here's another one. This is a really fun program to play around with. Just fooling around is a lot of fun. I'm going to clear the screen again, and I'm going to turn off the hen. So I'm still dragging my mouse around, but I'm just drawing the fox. Turn the hen back on, but I'll turn off the fox. So this is the hen's trail, and now we have both of them leaving a trail as they go. So this is the fox and hen program. I'll show you the key technique that's behind this program, and then we'll see what state is maintained to draw each frame. The basic trick behind the fox's nice behavior is nothing more than scaling an arrow. We saw how to do this in the video on arrows. To scale an arrow by some amount, we just multiply the x and y components of the arrow by that amount. So let's see how this is used in the fox and hen program. Here is the total state for fox and hen. On the left, we have all the information we need for the hen. I have the center of the hen circle, that's hen x and hen y, the radius and color of that circle, so I can draw it, and a boolean that tells me whether it's visible or not. And that just tells me do or do not draw the hen. That's everything I need to know to draw the hen. Similarly, I have the fox on the right. We have the fox x and the fox y, the center of the circle that represents the fox, the radius and color of that circle, and a boolean that tells me whether I want to draw it or not. At the bottom, you can see two more variables. The first is called move scale. It's a float, and it tells me how much to scale the arrow from the fox to the hen. That tells me how much the fox moves. I'll show that to you in a moment. The other global is just a boolean called clear background, and if that's true, I clear the background on every frame, and if it's false, I don't, and we get a trail. So the only really unusual thing here is move scale, and that's actually the heart of the program. Let's look down at our grassy field, and here's our fox, and here's our hen. And all those global variables are used to just know where these circles are, what color they are, what radius they are. Here's what I do on every frame. I find the arrow from the fox to the hen. The x-coordinate of this arrow is hen x minus fox x, and the y-coordinate is hen y minus fox y. The difference in the x's, the difference in the y's, they go together to make the arrow. and I multiply the x and y values of that arrow by the floating point number move scale, which is typically something like 0.1 or 0.05, and I get a much smaller arrow. Then I move the fox to the tip of that arrow, and that's it. That's the end of the frame. And now draw is finished. Notice that draw has changed the global variables foxx and foxy because we've moved the fox, but everything else is just the way it was. A 60th of a second later, processing wakes up draw again. Draw says, oh, good morning. I'm going to find the distance from the hen to the fox, draw this little arrow. I'll scale it by move scale, and I'll move the fox towards the hen. And I'm done. Now draw is done, but let's say before the next time draw gets called, we drag the hen. So inside of mouse dragged, I've now changed the global variables hen x and hen y. After a little while, draw gets called, and draw says, oh, well, I do what I always do. I draw the arrow from the fox to the hen, I find a smaller version of it, I move the fox towards the hen, I'm done. But I still have my hand on the mouse, so I drag the mouse. And now I've changed the value of hen x and hen y. The mouse handler goes away, time passes, draw wakes up, it says, oh, I know what to do. I draw the arrow, I find a short version, I move the fox, I'm done. That is the entirety of the fox and hen program. That little operation, just move a little percentage towards the hen, gives us all the behavior we just saw. All that beautiful slowing down and speeding up, all those beautiful smoothing out of the jittery motion of the hen. It just all comes from that. I've been saying that the code for this is very easy, so let's actually take a look at it. Here's draw. I've marked with comment lines all the other stuff for clearing the background and drawing things, and I'm just focusing on the two lines that move fox. The first line moves the fox in x, the second line in y. Clearly they're almost the same thing, so let's just look at the first one. It says fox x plus equals, okay, we're going to add something to fox x. So what are we adding? We keep reading. It's move scale times something, and the thing we're multiplying is hen x minus fox x. That's the x component of the arrow from the fox to the hen. This is just what we saw in the video on arrows. We are finding the arrow from the fox to the hen, scaling it, and adding it back to the fox. As move scale becomes smaller and smaller, fox x moves a smaller and smaller distance towards the hen, and then fox y does the same thing in y. The only other thing to think about is how we move the hen around. I use mouse dragged for that, and it is so simple I don't even need a comment. I just take mouse x and stick it in hen x. I take mouse y and stick it in hen y. That's all there is to it. So to recap, here is the entire state of the program. In the left, we have the 5 values that tell us about the hen. Where the hen is, x and y, radius, color, and whether we want to draw it. Similarly for the fox, we have the fox's x and y, radius, color, and whether we want to draw it. At the bottom, we have move scale, which is simply the fraction by which I scale that arrow, and the global variable clear BG, or clear background. So the mouse and the keyboard change some of these global variables. That is, they change the state between times when draw is running, and draw itself changes the state by changing the values of fox x and fox y on every frame. In the supplementary video, Writing Fox and Hen, we write this program together, from scratch all the way through to a complete program, so you can see how every one of these pieces can come together. Let's take another look at the running program. Here's our grassy field. For fun, I'll do it the other way. I'll turn on the hen with the keyboard. Now I'll turn on the fox, and now I'll start dragging the hen around. And the fox is just chasing the hen the way we just saw. And now I'll use the keyboard to change the clearing so that now we don't clear before every frame, and we get these beautiful trails. I'm going to really jitter around the hen a lot. I'm shaking my mouse a lot. And notice how smooth the fox is. That's just a nice side effect of this technique. So this is really fun. It's fun to draw with this. You can make a really interesting kind of a paint program out of this. If you start dressing it up, then you change sizes and colors and all sorts of other things. As long as we have access to these global variables, we can draw one frame. And that's all Draw ever wants to do, is draw one frame. And if the variables change, then Draw will draw a different frame. In other words, this picture still applies. It's always going to apply. Your state is the conceptual name we give to your collection of global variables and any globals the system gives you, like frame count. The keyboard and the mouse can change these. Draw can change them. And the key thing is when Draw runs, it checks those variables, it uses them to make a picture. If the variables change over time, the picture changes over time. If the picture changes over time, then if we're watching the pictures, we will perceive that as motion or animation. And in particular, if the keyboard and the mouse change the variables, and those variables result in changed pictures, we will perceive that as responsive interaction. So the heart and soul of this picture is the yellow box that contains the state, or the global variables. As those change over time, the pictures produced by Draw change over time. And that is how we create motion and animation in processing.